Anywhere.
This is a homemade rubber-tired locomotive that I've been working with for about 10 years. And I'm just going to describe a little bit of how it works. Of course, the big main part is the boiler, because you're boiling water to make steam. And the fire is in the other end, which is fired by wood. There's a firebox back there, just at the front of the cab. And then the fire comes through the tubes that you can see in there, and that gives you more heating surface. Otherwise, you wouldn't be able to boil the water fast enough by just having it in the firebox. So that's what creates the steam. And then most of the boiler is full of water. Up at the top, about the last 8 inches or so, is where that's where the water level maintains, and then the steam then is right on the top of the water. Now those domes that's up on there, normally in a locomotive, they have steam in the one and sand in the other to give the tracks, the wheels more traction on the steel rail. These are just simulated because this particular boiler didn't have a dome, a steam dome. Now on the inside of that steam dome is a 6-inch pipe that suffices for a steam dome, and what that does, it gets the outlet for the steam, which is that 2-inch pipe you see there. That gets the water separated further from the outlet, and it makes so you don't get water out of the boiler in the steam, because you want dry steam to work with in your boiler, in your pistons. Then that there's 2 valves right up there at the top of that 2-inch pipe that's coming out from the dome. One is just a shut-off in case something needs to be shut off. You have some kind of a defective equipment that you want to stop, you can shut it off up there. The next valve is the throttle valve, and that regulates the amount of steam that comes down the pipe. And it comes down this pipe, and then it divides here and goes to the cylinder. And the top part of the cylinder, this guy, is where the valve is that lets the steam in and out. First, it lets the steam into the piston, which is here, and pushes the piston back, and then just before it gets to the back, the crank mechanism on the wheel causes this valve to close and begins to open, so that the steam that has just pushed in here can escape up these pipes into the smokestack, which creates draft and brings more fire out of the boiler, out of the firebox through the boiler and up the stack. So you create your draft by the exhaust, and then it's just a reciprocating process as the valve goes back and forth. It directs steam into one end of the piston and then into the other end of the piston. So it's really a smooth operation. And of course then the 2 pistons are 90 degrees to one another in the position that they are on the wheels. And that is so that you always have got some piston pushing somewhere, or pulling, whatever the case might be, so that you don't have a dead spot. Otherwise, if you had them together, you'd get to where the piston once had to return, and then there wouldn't be anything to carry it along to make it go to continue because you don't have a flywheel. See, most steam engines, like tractors, they have a flywheel, and that carries it over when you've got that dead spot. But here on locomotives, you got to have 2 cylinders, and they got to be 90 degrees to one another. So the rest of this mechanism here changes the direction of the piston, of the valve, because you may need to reverse. When you pull it clear to the top here, then that reverses that and puts the valve in the other end, and then it'll go backwards from what it, so. Well, that's a similar thing in all locomotives. They have that. So, and that's cool up there. Now, while we're out here looking, the little valve up there on the top is a pop-off valve and that's set at 100 pounds of pressure, which is the boiler's capacity for pressure. Now, you know what to set that at. You calculate all of the construction of the boiler, how many rivets, how thick the metal is, and all that, and you come up with a operating pressure. And so then, when you go to test it to see if it's safe to use and doesn't have any leaks, the inspector will come and then you'll do what's called a hydro test, and you'll pump up 1.5 times the operating pressure. In this case, it was 150 pounds, means we had 100 pounds of operating pressure. And then that has to satisfy that pressure, not have any leaks or anything that's causing problems. And then, of course, that's determined, like I say, by how the boiler is made. So there's a certain, if the boiler is made heavier, you could have higher pressure. Locomotives usually they have heavier material, and they use more pressure, like 200, 250 pounds maybe. This little device right here is just a check valve, and the water that you have to add water as you're using the steam. As the steam is coming out, water's boiled away. You have to add water. So this line here is a water injection line, and it adds water right while you're using it. This is the device that does that. It's called an injector, and it brings steam from this pipe here into this injector assembly and forces through a little venturi inside, and then that picks up this cold water and forces it down in right against the pressure that's coming out of the boiler to make it operate. It's like lifting yourself with your bootstraps, but it works. So I don't know how somebody could have figured that out, but they did over the years. So that's on. We have to have 2 injectors. There's another one just like it on the other side of the bike, because if one fails and you can't add water while you're fired up, you've got troubles. You got to either get rid of the fire really fast or add water some other way. So that's a safety feature to have two items. Okay.